recording. Okay, so today we're going to be talking about 7.1 and 7.2, the beginning, almost like the beginning of the end. So we're going to be talking about OOP.
Yep.
Uh, okay, so let us start. So the first thing that the book does is acknowledge the whole like popularity of this idea,
Yep.
even though it also assumes that there's a lot of vague stuff out there,
Which there is.
and we're going to try to we set out some motivations. So actually, yeah, so this is the structure of the chapter. We're gonna try to have some definitions here. That's I think what's important from this part. So inheritance. So what is this? So this is the trying to make the commonalities between different pieces of code in a single place. So then you don't have to change them all.
Yep.
So that's why you would do that. An ADT can be defined to inherit from other ADTs. That is to have substantially the same functionality as the others with the possibilities of some modifications and extensions. Only the differences between them have to be specified. The common parts we can just take them for granted. So OOP is actually an extension to the stateful model, which inherent is the essential difference between OOP and most kinds of stateful programming, but is just like a way to use a particular use of the stateful model. And then there's the caveats in here. So it turns out that inheritance is a very rich concept that can be rather tricky. There are many ways that an ADT can be built by modifying other ADTs. The primary approach used in OOP is syntactic. A new ADT is defined by doing simple syntactic manipulations to an existing ADT. Because the resulting changes in semantics are not always easy to infer, these manipulations must be done with great care. And then he compares again with the component-based approach that we've seen before, saying that a component groups together any set of entities and treats them as a unit from the viewpoint of use dependency. A component is built from some subcomponents respecting their
Uh,
specification.
yeah, one thing actually that we should point out, you can do inheritance without mutability. It's just that's rare for some reason.
Well, but in the way that it's being defined, that's on how that's going to work. Because it's specifically saying that we're going to use the stateful model under the hood to implement that. And as we will see
No,
in the
no, no, no.
code, that's actually what happens.
Well, yes, but actually the parts that actually implement inheritance itself, they are not mutable. Like the
Well,
fields of the object are mutable,
that's
yes.
7.3, and I haven't read that, so I don't know. But if you're saying that we could do that without making them mutable, sure. Sure, sure, sure. Um, and then there's the whole promise, right? So we are promising you that everything's going to be perfect because we're implementing the abstraction only once. Um, we're not going to have the problem of having to change multiple places. But then this is a two-edged sword. It comes at the price of spreading out an entity implementation over larger parts of the program. So you have like a stack of inheritors, for example.
Yep.
The implementation of the DT does not exist in one place. All the DTs that are part of it have to be considered together. If a stronger part of the implementation may exist only as compiled code, so you don't have with no access to the source code.
Yeah.
Early on, it was believed that was a silver bullet, but it seems that hasn't paid off. Um, Inheritance is not an mixed blessing, but it takes its place next to higher order programming as one of the most important techniques for structuring the program. So now, encapsulating state and inheritance. um, so most OOP languages consider ADT should have explicit state by default. For example, Smalltalk, C++, and Java all consider variables to be stateful, mutable by default. In Java, it is possible to make variables immutable by declaring them as final. This goes against the rule of thumb given before, and in our view is a mistake. Explicit state is a complex notion that which should not be the first one that students are taught. There are simpler ways to program using variable identifiers to refer to values or data-flow variables. The simpler way should be considered first before moving to explicit state. Okay, so now we're gonna get into an example of having a class implemented.
Yep.
And as you can see, even by the syntax, this is assuming mutability from the start. This is assuming mutability from the start.
It is, but it doesn't have to. It's kind of sad that this book does this, but then, well, I suppose it is trying
But the
to.
way that it is defined, it could not have done in a different way. It is defining by its own premise that OOP is an extension of the stateful model. So it would actually be kind of weird that they said that, but the implementation doesn't do that.
Which is fair, but it's not strictly necessary.
So how? Okay, so There's a lot of vocabulary as well. So very common vocabulary. So now it's introducing the notion of objects. It's introducing the notion of methods and a class. And just something that a curiosity that I had reading this book was that, will this book show me why in the beginning of times OOP was related to message passing? And 7.2, like, there are some pieces of this code that is taking advantage of having the data flow variables for the message passing.
We're
But
gonna
that's
see that
more.
when we get.
Go
We're
ahead.
gonna see that when we get to active objects. That's chapter 7 point. I forget the number, but it's later.
Yeah, but that's bad in my opinion, because if OOP in the beginning was related to messages, you should demonstrate to me why that was the case now, because you're introducing the OOP now. And in some sense, they are taking advantage of that, because there are some properties that we're going to see that rely on the fact that we have data flow variables in the specific case of their implementation. But some of them are also due to the dynamic typing. We're going to get there, but I just want to just wait, like say that I wanted this to explain to me this relationship. Uh,
Uh, well, it's actually not like people say about message passing as if it was a magical thing. It's literally saying, okay, we're going to treat the object as if it was a server, and calling a method, it's like making a request on the server where you have a label, which is kind of like a URL, right? And it has parameters, and you wait for a response. Um, but you can talk about the message without like actually calling the methods that it denotes, you see? Which is not something that's done in mainstream OOP languages for some reason.
yeah, but that's because for them they are not implementing the calling of a method as a message at all. You only do that if you already have that built in, right? For example, in this implementation, when you say calling a method is sending a message, that's not only a philosophical or abstract notion or a way to think about it. That's the way that it is implemented. That's why they are talking in those terms. But and that's one of the reasons that I think it's related, because in OS they actually are leveraging a message passing mechanism to implement the method. It's not only a way to think about it; it's actually how it is done. In the
Yeah,
other
we
languages,
actually
they don't have that notion. They don't talk about it because they don't have it. They just don't have it.
yeah, we actually see a very clear example of that when you get to active objects, because an active object is actually has a thread associated with it. So when you call a method on it, you are literally sending a message to another thread, you see?
Yeah. Um, anyway, so we introduced the notion of the nomenclature. Um, this is how it's gonna look like. But this is just syntax sugar, really. So then we have uh, classes as complete EDTs. So you can have a complete EDT definition, which means that defining the various elements that make up a class, namely methods, attributes, and properties. Attributes can be initialized in several ways. Taking advantage of dynamic typing, this gives first-class messages and first-class attributes. This allows powerful and dangerous forms of polymorphism that are difficult or impossible to do in a static context. This increased freedom comes with an increased responsibility of the programmer to use it correctly. Yeah, we're gonna see the runtime generated methods and attributes, which is kind of crazy if you think about it, because that basically means that you can have a window open. Like, so this is a security problem. Incremental EDT definition, which is what we're going to use inheritance for. So you already have something, you want to build something on top of that. So that's incremental definition. And then we have an example. So blah blah blah. I don't think we need to go over the syntax because it's pretty self-explanatory. This is the name of the class. This is the name of the mutable attribute. And attributes are mutable cells by default. Then we have the methods, which we're going to discover what they are shortly. And they can receive stuff. And you also have some sort of lexical scoping going on because you have access to this val in here. And this is the syntax
Yep.
for changing the value. This is the syntax for reading the value. And this is them both combined. But there's another built-in operation which is kind of weird. I don't know if... Yeah, we're getting there. Anyway, now it is basically describing how we're gonna make that happen. So it's similar to the proc definition, to a procedure definition. Blah blah blah. Yeah, this is how you create stuff, right? So let's create an object and do some operations with it. This creates an object, increments it twice by 6. This syntax is also a little bit like towards the idea that you're sending a message, at least in my opinion. Like, it seems like you're sending this message to this object, just
Yep.
syntactically. Like, that is not necessarily how that works, but in this case, it looks like that's what's happening. The value 6 is called an object application. This message is sent to an object, which invokes a corresponding method. And then if we do this example, this doesn't work because x is a data flow variable, which means that this guy is blocking because this is not bound when you're doing the increment receiving. So if you have increment, you need to know the value in order to do the plus with it. And we don't have that because x is unbound. So this displays nothing at all. And the reason is that the object application blocks inside the increment. And if you put that inside a thread, and you make some synchronization mechanism using this unit here for the main thread, now this works. And the reason is because this is gonna block inside the thread, and the main thread will unbound it by using the assignment. Like, very common trick. Very common trick. Semantics of the example. So this is where we have the weird operation, I believe. Is that it? No, not yet. Um, Figure 7.2 shows that what server 1 does by giving the definition of the class counter in the stateful model without any class syntax. So this is 7.2. Yeah,
Yep.
so this is the desugared version of what is happening on the thing.
Indeed.
On the thing. Nothing too crazy, right? So we have procedure for init, which is essentially doing the initialization. This is like close to what people call a constructor.
It is
Uh,
a constructor, semantically, right?
um, sure, sure. So it receives this M and there is this S, and you actually just like um, equaling them around. You have browse to, and you have increment, and then you create the counter here, and you put those operations inside a record like that. So far so good. We can see that according to this definition, a class is simply a record containing a set of attribute names and a set of methods. An attribute name is literal. A method is a procedure that has two arguments, the message and the object state. So M is for message, if you go back. M is for the message and S is for the state. So
Yep.
you are extracting, like pattern matching, in quotes, the message to retrieve the value and then applying that into the mutable state. Um, yeah. In each method, blah blah blah. Yeah, this is the new syntax that we are going to introduce. Figure 7.3 defines the function new, which is used to create objects from classes. This function creates the object state, defines one argument procedure object, that is the object, and initialize the object before returning it. So if you go to 7.3, this thing. So this is what happens um, when you're instantiating a new instance of a class, aka creating an object. So you have the name of the class and you have the initial value, and then this is where
Uh,
we're creating the mutable cell here
well,
for
technically,
each
that's
one.
the initial message, right? That's going to call the init method in this case,
Yeah,
in this example.
this is the initial message, right?
Yeah.
We are making this internal procedure, which is basically grabbing the message and pushing it further, and the initial message is init, as you can see in here. So nothing too fancy, nothing too crazy. Mm. A class is a data structure that defines an object state, its behavior, the classes it inherits from, and several other properties and operations that we will later see. We have instances of that. Yeah, this is where the important part. An object obj is called with the syntax, where M is a record that defines the message. Calling an object is called sending a message to the object. This terminology exists for historical reasons. We do not recommend it since it is easily confused with sending a message on a communication channel. An object invocation is synchronous, like a procedure's. This invocation returns only when the method has completely executed. That's why we needed to put that in a thread in order to not be blocked.
Indeed.
Yeah, this is now we are getting to the operation. Okay, so in object-oriented terminology, we have members, and two of them are very popular, but I never seen this name being used for this type of stuff. But I guess it makes sense. So now we have attributes. An attribute is a cell that contains part of the instance state. An attribute is often called an instance variable. The attribute can contain any language entity. The attribute is visible only in the class definition and all the classes that inherit from it. And what can you do with it? You can do an assignment statement, which uses the colors equals syntax. You can use at to read it, an access operation. And so far, this is like everybody understands this. And then there's this one, an exchange operation. If the assignment this is used as an expression, then it has the effect of an exchange. For example, consider this statement. So you have an expression 3 equals expression 1 column equals expression 2. This first evaluates the three expressions, then it unifies expression 3 with the content of expression 1. So this means like pattern matching in a way to like get parts of it, and atomically sets the new content to expression 2. The new content, my understanding, is expression 1.
The new content of the cell denoted by expression 1, which is actually, well, it's actually, in this case, it's an attribute of an object, right? But internally, it's a cell.
Yeah, no, but just to clarify what's happening. So you are unifying this with this, but the one is this is going to be the one after unifying that will be inside the contents of 2.
No, expression 3 is like you're doing an assignment which is atomic, but you're also in the same atomic step you are grabbing the previous value of the attributes and binding it to expression tree.
I don't think that's different than what I said. Assignment is the unification, right? In this
Yes,
language, assignment is the unification. But you're grabbing the content, so you're doing two operations in a single step,
yes, it's atomic.
which means
So
that you are unifying. So if they are variables, like if they are literals in expression 1, for example, and they are variables structured in a way that match the literals on the expression 1, the variables containing 3 will be assigned.
yes, they will be.
And the content in here, which is being used for that, is also being put inside this cell.
No, no, the cell is expression 1. We're reading its contents, unifying the content, the previous contents with expression 3, and expression 2 is the new contents, and all of that happens atomically.
Oh, expression 2 is the new content.
Yeah,
Okay, so you grab the old content, unify with this, so you're basically saving it as a backup, and grabbing this and put it in here.
yeah,
The contents of this, I should say.
yeah.
Okay. Methods. A method is a kind of a procedure that is called within the context of a particular object and that can access the object's attributes. It has a head and a body. The head has a label, which must be an atom or a name, and a variable. Yeah, this difference is very subtle in the beginning because, like, of course it's gonna be a name, but what it means by saying name is actually like a variable, and we're gonna see how that's gonna be. That those are two very different use cases. The arguments must be distinct variables, otherwise there is a syntax error. For increased expressiveness, methods heads are similar to patterns and messages are similar to records. And then we have properties, which is essentially like um, how how do people call that in modern OOP?
Uh, don't quote me on this, but I think Java calls these things the same concepts like modifiers. Like you can add a
Ah,
final modifier to a field declaration, for instance.
yeah. Protected, I also think it's a modifier. The property locking creates a new lock, so this is just an example. So these are basically like
That's for concurrency, yeah.
no, not specifically this example, but the locking example and the final example, they are examples of the phenomena of describing. You're describing properties or characteristics of something.
Yeah.
So you're if this is final, this means something else. If this is protected, this means something else. Like they are extra modifiers, but I think properties and modifiers, they are okay names. Attributes and methods are literals. If they are defined with atom syntax, then they are atoms. If they're defined with identifier syntax, then the system will create new names for them. The scope of these names is the class definition. Using names gives a finer grained control over object security. In addition to have this kind of members, the next section shows how to inherit how a class can inherit members from other classes. Well, this is actually not surprising given that you can even have a runtime everything. You can have runtime attributes. You can have such as these ones. You can have runtime method names. So if you have that, making this is just like why not?
Oh, yes, classes also exist at runtime.
Yeah. So attributes can be initialized in two ways. This is also very classic, but I think that my understanding is that the second way is not recommended for C++, or at least it was not recommended 10 years ago. Because again, I was watching Jonathan's talks, and he said that apparently in those days you were strongly incentivized to make constructors for these things, not to put default values in the class.
Uh,
Which is like one of the first things that he mentions that Jai will have.
right.
Uh, okay, so then we have per instance, which means that you're receiving something. Yeah, this is not as crazy as I got confused. This, yeah, this, no, not this. Where is the craziness? We're gonna reach some craziness that it's not this. This is just normal, right? So you have a class that if you have a method init, it receives something and it saves in the thing. It saves something in the thing. Actually, this is not saving anything. This is just unifying.
Well, no, technically it is because street name is the name of an attribute, which is a mutable cell, right?
Yeah, but you're not using column equals.
That's because the attribute is initially defined to be an unbound variable. So unification binds that.
Yeah, so you're doing unification, right? You're unifying the contents of this, which is unbound, with the contents of this.
Yeah.
Each instance including okay, so this means that you can create two objects and you can initialize their initial values differently. And you have per class, which is just adding default values for attributes. And you
Yeah, the
use the
thing is,
column
yeah,
syntax.
the thing is, those are not really default values. Those are values that are the same for every object of this class, right? It's slightly different.
Yeah, I guess that's true because this yeah, actually it is written in here that if wall color is unbound and one of the instances binded, everyone else will get notified about that bind. So actually, you're right. These are not default values. These are more like default values, almost like
Yeah, this is
static, almost
yeah,
like a
those are
static.
yeah, those are like static fields in Java, for instance,
Exactly.
which
So
is
yeah,
associated with the class as a whole, not with particular objects.
yeah. So if you do this unification here, everybody will get notified. And those are two different statements. So this is the unification, and this is the assignment. This is the assignment. Just to wait. The difference between unification and assignment in this case is that in here you are unifying the contents of this with this atom, and in
Yeah,
here you are changing,
the contents to be this atom.
yeah, to be this atom. You're not unifying them. You're just replacing. That's the difference. Per brand, which this also seems like I never seen this nomenclature before. Per brand, because it essentially mean like flags or like feature flags. So you have a value that is globally defined, globally in the sense of a scope, and everybody else is just using that as we define the stuff. So usually you just use a feature flag for this, right? So if
Yeah,
if your operating system is Windows, we put Windows in here, and if it's Linux, we put Linux, and everybody else just follows along. But I never seen this name before per brand. First class messages. Yeah, this is the real weird stuff. So static record as a message. In the simplest case, M is a record that is known at compile time, such as this one. But there is also dynamic record. It is possible to call object M, where M is a variable that references a record that is calculated at runtime. And the reason that we can do this is because we have access to these functions at runtime. It is possible to create new record types at runtime.
yeah,
So that's the object call. Now about the method definition. This is also very cool. The method head is a pattern consisting of a label followed by a series of arguments and parentheses. Yeah, so we are basically constructing the method. Like you would imagine that, I don't know, we're gonna make a special case for methods, but no, we're just gonna use what we already have built for the kernel language.
yeah. We have pattern matching. We can do destructuring, right?
The method head full is a pattern that must watch the message exactly, and this is again another reason to correlate to message passing, because we are actually, if you think in Erlang terms, a method is a receive with a name.
Yeah,
So the label foo and arity ABC must match. The features ABC can be given in any order. A class can only have one method definition with a given label, otherwise there is a syntax error. This is a little weird because this means that you cannot have overloading.
You cannot have overloading, indeed.
Flexible argument list, and again, this is also very crazy. So you have variadics in the method definition. So it accepts at least the listed arguments. This means that the same as the dots in the case statement, the given label must match the message label, and the given arity must be a subset of the message arity. And now variable reference to a method head. Again, data flow variables all the way. So the whole method head is referenced by a variable. This is particularly useful with flexible argument lists, but it can also be used with fixed argument list. So you can do this. The variable m references the full message as a record. The scope of m is the method body. Um, yeah, but this begs the question, where is m coming from, right?
Well, it's a fresh variable.
Yeah, but this means that you cannot like externalize it, right?
Well, you can return it. You can bind it to something, to an external reference that comes in as an argument.
Yeah. Optional argument. So default values for arguments in methods. So this syntax in the method means that the field B is optional in the object call. That is, the method can be called either with or without the field. With the field, we use the value that came from it, and we ignore the expression v. If it doesn't come, we just rewrite it like this. And then we have private method label, and that's where it gets interesting because a is not an atom, it's a variable because it's capitalized. So that's what it was meant by names. We said that the method labels can be names.
Uh,
This is denoted by using a variable identifier.
yeah, because the variable, like the class will instantiate a fresh name, which is unique, right? Because that's the semantics of generating a name. And it's going to bind it to that variable so you can refer to it in the class, but it doesn't, like nobody else knows the name, so nobody else other than the class can call that method. It's basically a way of making a private method, essentially.
Yeah, if it has to be used elsewhere in the program, it must be passed explicitly. So that's why it's classified as private. And then there's an even more crazy shit, which is it is possible to calculate a method label at runtime by using an escaped variable identifier. This is possible because class definitions are executed at runtime. The method label has to be known when the class definition is executed. So this means that if you are running your program and you have a variable called a, and immediately after that you define a class that has this inside of it, you are creating a method for that class that has the whatever is bound to this variable at that time.
Yeah, so
So
like
like
if you if you
this is the wet dream of Lispers with macros and metaprogramming, because you can they love doing that. Oh, I can just generate this with a macro and I can have my stuff being generated. You can just do this instead.
yeah, you can just take, like you can just make a procedure in this case, right? That can take the a as an argument, and then you can splice the a as the method name. Like that's, you don't really need macros for that.
And then we have the otherwise method again, Erlang analogy. This is the catch-all. The method head with label otherwise is a catch-all that accepts any message from which no other method exists. A class can only have one method with this because, well, it's gonna for the same reason that a catch-all can only be one. This method must have just one argument, otherwise a runtime arity mismatch error is given. If this method exists, then the message accepts any message. If no method is defined for the message, then the otherwise method is called with the full message in name as a record. This mechanism allows to implement delegation, an alternative to inheritance explained later. This mechanism also allows making wrappers around method calls. In general, the compiler tries to determine statically what the object and the method are. If it can, then it compiles a very fast specialized call instruction. If it cannot, then it just compiles a general object call instruction. The general instruction uses caching. The first call is slower because it looks up the method and caches the result. Subsequent calls find the method in the cache and are almost as fast as a specialized call. This is what I'm talking about. Attribute names can be calculated at runtime. For example, it is possible to write methods to access and assign any attributes. This sounds dangerous as fuck. Especially this. Like, I'm giving you full-blown access to my attributes because you can just give me a variable and I will, and like this is also doing very clever tricks with scoping. Um, yeah, it's doing some very clever things with scoping because you are leveraging the fact that this syntax has a special meaning within this context of the class. So you are actually, if there is a variable, an attribute in this class that has that is bound to the same thing as this A, you are mutating the internal attribute of the inspector by doing this.
Yeah,
So this
you
is
are.
like, what the fuck is going on? The get method can
Well,
access any attribute, and the set method can assign any attribute. Any class that has these methods will open up its attributes for public use. You should not do that. You should
yeah,
not
it's
do that.
dangerous. It's useful for debugging, as it says, but it's dangerous for general programming.
Oh, we're already done. Okay, that's gonna be one of the fastest sessions in history. The class concept we have introduced so far gives a convenient syntax for defining entities within encapsulated state in multiple operations. The class statement defines a class value which can be instantiated to give objects. In addition to having a convenient syntax, class values as defined here keep all the advantages of procedure values. All of the programming techniques for procedures also apply for classes. Classes can have external references just like procedure values. Classes are compositionals, they can be nested. They are compatible with procedure values. Classes can be nested within procedures and vice versa. That is because classes are only defined at runtime. Classes are not this flexible in all object-oriented languages. Usually, some limits are imposed. Well, we've seen a lot of them. As far as I can tell, you cannot do this type of shit in any language, like aside
You
from this
might
one.
be you might be able to do it in Smalltalk.
But does Smalltalk have data flow variables? Because this is also relying on that, right?
Not really, because here's the thing: the get, yes, it is binding a data flow variable, but that's equivalent to a function call because it's only binding one variable, right? So you can just use the return value of the method in this case.
Fair enough. Fair enough. Yeah, we have like loads of time. So do you want to talk about anything specific?
I wish more people knew that you can implement objects as procedures with lexical scoping. For unfortunately, that's not as common knowledge as it should be.
Well, but there are a couple of reasons about that. Because I was kind of thinking about the whole lexical scoping trick that this book uses all the time. And the reason that I don't think nobody does that is because the lexical scoping rule for those languages, they kind of get mixed with the memory allocation rules. So imagine if you have a C function and you define something within there. After you get out of the scope of the function, if you didn't malloc that, that variable is gone.
That is fair, but
But in this language, that doesn't happen.
yeah, there's no reason for to have that restriction if you have garbage collection anyways, right?
No, yes, but I think that the fact that most languages work with this memory model influences the decision that first they will never even think. Like, I'm gonna use Jonathan again. He thinks that if your language is garbage collected, he's not interested in you for game development.
Which is fair.
So I think there's a lot of that. There's a lot of like everybody's used to this. Everybody's doing this for like decades. And everybody knows that if you're allocating something in the stack and you get out of the scope, it's gone. In this language, that's not true. Like,
That's yeah, That's not true in garbage collected languages in general, but this one is really making a point, right?
I don't, well, I never leveraged that fact in any of the garbage collected languages that I ever used.
You've never returned a function from another function?
But that's not what I'm talking here.
It is. It is exactly the same thing,
It
actually.
is not exactly the same thing. What I am talking about is that you have a greater scope. So when we, for example, we're making an ADT, right? So you're making a bounded ADT. So everything is within a very defined global scope, not the very defined scope. If you make a variable such as this local x inside there, actually I think we can we probably have an example of this. Yeah. So in this scope, like imagine that this was something that you could call, not only a local. If you declare something within here, such as an x, for example, and later you call one of these, the x is still intact. The
Oh
whole
yes,
notion
this
of
is.
getting out of scope, even for a bounded variable or unbounded variable, whatever, this still applies. That still applies. What you said about higher order programming, it's true in the technical sense, but that's not exactly what I mean. I mean like something closer to like what people usually call variables. So you do if
Oh
you do
yeah,
an int
like.
x in whatever, and that's in the stack, after you're out of it, you're gone. In here, if you have an x, a capital X, that's not necessarily true. Even though they are both being, well, they are not exactly the same type of variables. One is much more powerful than the other, but I think that's one of the things that I think people, some people I even would bet not even thought that would be possible. Like, wait,
They they never knew about the fun art problem and that it's been solved since like the 60s or whatever, right?
what problem?
The fun art problem.
I haven't heard of that one.
Basically, it's a problem where you want to either take a function as an argument or return a function from another function, and how to deal with that in the face of stack discipline, right? Uh, or rather, also how to this involves like rules around what happens if you define a function inside of another function, right? Like for instance,
Yes, yes,
Algo
yes.
you can define nested functions, but you can never return a function.
No,
So
but you
because it
can't
doesn't have
return. No,
closures.
but you can't return a function. Like that's not. Well, in C you would return a function pointer, right? That would be just an address. If that
Uh,
function was being defined hypothetically within the local scope of the bigger function, I understand your point. But if you have a function and you have another function and you want to return a way to go to the other one, you just return a function pointer of it, right?
oh yes, the point is like if you have nested scopes
Yeah, then I
and
understand.
yeah, if you have nested scopes in the inner scope you define a function, a local function.
Yeah.
Can you pass it as an argument to another function and can you return it? Those are the two questions, the two
Yeah,
halves of the
that
fun
that
arg
makes
problem.
total sense to be like a big deal. Not necessarily
Yeah,
today, because as you said, people are solving that since forever.
yeah. The solution to I think it's the upwards, no, the downwards problem, which is passing a nested function as an argument. That's easy, right? It's just a function pointer. Returning a function, that's the upwards fun arg problem. That requires closures, and
Yeah,
not every language does that.
yeah, exactly. Makes total sense. That the downwards one, you just pass a function pointer, like just use it. You may have some convenience, like for example, I guess C++ lambdas maybe, or maybe even Java lambdas. I don't know how they work, but and the upwards problem is actually the big question because are you gonna do closures or not?
Yeah. And if you are doing closures, then if you're a low-level language, well, tough luck. That requires an allocation, right?
Exactly. Like if you are doing closures in a low level, you need to like do either make a compiler error that mandates the programmer to do some allocation manually, or you're gonna do it automatically. And that's what I think people like Jonathan doesn't like, don't like. They like to
Um,
have full control. They rather have a compiler error than having a convenience.
yeah, if you have a compiler error, that leads you to basically implement closures manually by defining a struct and returning the struct and an associated function pointer,
Which
right?
is what's I guess the reason that doing lambdas in Zig is so fucking painful.
Because you have to do essentially that, yes.
Makes total sense. Yeah. Anyway, so the lexical scoping of this language allows you to do very crazy shit. Uh, Precisely because it has. And I was thinking about this. I was like, man, why haven't I noticed the lexical scoping can do all this shit? And
Because
then
we
it
never
came to
thought
me.
about it.
Then it came to me. It's because this lexical scoping allows you to keep stuff after you're out of the scope.
I mean, you can do literally the same thing in Lisp, in Haskell, in ML. You just need closures, basically.
Yeah, no. Um, yeah, you just need you can implement that via closures, but I never thought of like I have a scope in Haskell and I have a thing, and every time I enter that scope, that thing is saved from the previous entering.
By the way, there's a Lisp book named after this phenomenon, actually. It's called Let over Lambda.
Okay, good to know. Anyway, so I think this is the one of the reasons that people are not talking about this because nobody is thinking in those terms. Everybody's just thinking either is on the stack or is on the heap, and if it's not on the heap, after the scope is done, you're done. Uh, and it's very I classify as a modern thing that imperative languages are even considering to have something like closures. And I don't
Oh,
think
jokes
Jai
on
has it,
them.
by the way.
Yeah, jokes on them, because as you can see in this translation, objects kind of imply closures, right?
Well, most of this book implies closures, right? Like the whole security thing, the whole being bundled or not, all of that stuff
Well, yes.
relies on the
Well, yes.
lexicoscoping works this way.
Yes.
Which is not a bad thing. I'm not saying it's a bad thing. It's just that I didn't realize that. Okay, it's not that I didn't notice that lexicoscoping was this powerful. It's that because I never considered lexicoscoping working particularly in this way. So, yeah, yeah. Cool. So I think we can finish for today. Do you have anything else to say? Oh, let's define what's gonna be next. So next,
You gotta do that. Yes.
well, not next Sunday, but the next Sunday.
Yeah.
We
All
have
right.
two.
For people, yeah,
Yeah,
for people watching the recording later, this we're recording this on a Thursday
yeah,
because we
it's
have
in
stuff
on
to
the
do this
calendar here.
Sunday. Yeah.
Yeah, we're gonna have two more sessions before my vacation though. So like the next Sunday, then another Thursday, and then I'm gone for 2 weeks. So let's see how much ground can we cover. So 7.3 is 20 pages. No, 17 pages. 7.4 is 19 pages. So 19 plus that's 36 pages, man. Okay, so do you think it's doable 7.3, 7.4 in a single hour?
7374.
It's 36 pages.
It might be.
Might.
Might be.
Okay, so let's settle 7.3, 7.4 for the next Sunday, and for the other next Thursday, let's see if we can do 7.5, 7.6. So this one is 9 pages, and this one is 4 pages. Okay, so we can do more. This one is 7.
We can just finish the chapter, no?
Yeah, I think we can try to do. Yeah, that's actually a good milestone. So the next Sunday we're gonna do 7.3, 7.4, and the next Thursday we're gonna finish 7, and then we're gonna go back after Christmas. We will be back on 8, and then we discuss
And
that.
we're gonna talk about locks
We're
and other
getting
related
closer to
things.
relational programming. Finally, freaking finally.
Yeah. Okay, I'm gonna finish the recording now.